Hey everyone, welcome to another Advanced Sports Analytics application tutorial. In this video, we're going to be covering our NFL player correlation application, which has really been one of our flagship programs for much of ASA's existence. The purpose of this tool, I guess, is multiple in nature. The idea behind correlation is that it allows us to get an understanding of how multiple players, two players really, relate to one another in their fantasy performance on singular weeks. So we're aware, I think, of players' range of outcomes and distributions, that players based on their talent level and opportunity are likely to score some fantasy output on some range of distribution. However, depending on how players relate to one another, there are higher and lower likelihoods of players simultaneously reaching similar levels within their distribution of possible outcomes. Two players that are positively correlated have a much more likely, I guess, chance and opportunity to reach, upper quartile outcomes on their distribution, while two players who are negatively correlated have really slimmer odds of both achieving upper quartile or true kind of top 10% ceiling performances within their own distribution in the same game. And correlation is a good, I think, catch-all or general, I guess, metric for understanding how players relate to one another, both in the direction of their relationship. Does player X performance typically align a positive, ceiling performance for player X typically align with a subpar or negative performance for player Y? That would be an example of two players that negatively correlate. Or are two players positively correlated? Does the ceiling performance or floor performance of player X typically align with a ceiling or floor respectively performance of player Y? Correlation is linear in nature, so we have a XY scatter plot, I guess, of players X and Y performances over time, where each point represents a single game in which player X and Y were active, and correlation attempts to identify or quantify the straight line that we would possibly draw through that scatter plot. So I think just before, or a good place to start is actually visually looking at the plot tab. So for example, if we wanted to look at correlation between Jared Goff and Cooper Kupp, we could do that. We could type them in player set 1, player set 2, and you can type in multiple players here. So you can type in like Robert Woods, apply changes, and you'll get the correlation between player set 1, Jared Goff, and all players within player set 2, Robert Woods. You could even add Cooper Kupp to player set 1, and then you would get correlations between Jared Goff and Robert Woods right here. You get correlations between Cooper Kupp and Robert Woods, and then correlations between Goff and Kupp. And you can sort these different columns. So positive correlation, meaning when Jared Goff reaches a ceiling performance, it's more likely that Cooper Kupp reaches a ceiling performance, and vice versa. When Jared Goff fails, it's increased likelihood that Cooper Kupp fails. We also have a sample size column, just how many games these two players have played together within a date range, so you can filter on date range. The Rams team has remained, at least their receivers have remained pretty stable over the last 2+ years. But if you were looking at a team where, I don't know, you wanted to look at the correlation between Will Fuller and Deshaun Watson, and in 2019, Will Fuller was wide receiver 2 behind DeAndre Hopkins. In 2020, he's in some different, roster or kind of depth scenario where he's kind of wide receiver 1, I guess, ahead of Brandon Cooks. Sample size. And then the combined max. This is a column we recently added to an update to the application, and this is just showing the maximum combined points that Goff and Cup have scored in the same week. So while Goff might have a ceiling of, I don't know, say 40 points, and Cup has a ceiling of, let's just say 50 points. I don't think he's ever gotten to 50, but let's just say he had a 50-point ceiling. It doesn't necessarily mean that both of those players hit their ceiling in the same game. I think for this actual example, these two guys did hit their maximum score within the same game. But if you take, like, I don't know, Cup and Woods, I would guess that, Cup has some like 40-point ceiling and Woods has some 30 to 40-point ceiling, but in no one game have they both reached their ceiling. The maximum combined score that they've reached in this 2+ year window, 64.3. But really, the metric that we pay most attention to is this correlation metric. It's like a R value, and really what we're showing, or what this correlation is measuring, is how steep is this line, this fit line, this orange fit line that goes through these data points, and how tight is it? Golf and Cup have this strong correlation that is, the one reason it's strong is because this this cloud of data points is quite tight, right? Like when as Golf's production increases, Cup's production has increased as well in a pretty tight and low variance fashion. Therefore, they have this really strong correlation. 0.6 is a strong correlation. Correlations range from -1 to +1, and +1 means that the performance of X perfectly indicates the performance of Y, and we just know in many mathematical instances that just is never the case. And in daily fantasy, or just sports in general, the linkage of two outcomes are rarely related to one another in some super pure predictable way. So this is looking at Cup and Woods, and it's always just going to plot the first two players in each set. So even though we have multiple players, it's just plotting Golf versus Cup. If we wanted to delete out Cup and then apply changes, we now see Golf versus Woods. And we saw in our table that Golf and Woods have this positive 0.24 correlation. I think it's just useful to see what that looks like. So in general, we see this kind of fan of data points where, as Goff's production increases, in general, Woods' production tends to be higher as well. But one reason, or really the reason why we're seeing lower correlation between Goff and Woods, is that this cloud of data points is really not quite as tight as Cup's. Like, there is more variance in Woods' production relative to changes in Goff's production than there is variance in Cup versus Golf. So that's why you see kind of that lower correlation number. It's also worth noting, like I mentioned, correlation is a linear measure. For Cup, we have a pretty straight fit line. Like, the best fit line that runs through this data is fairly straight. This is what's called a lowest regression line, so a local regression. So shaping of the fit line relative to local or near points to the point on the scale that we are considering. But if we were to draw a straight line through this cloud of data points, it'd be pretty straight all the way through. There's a little bit of variability in this kind of middle range, but for the most part, pretty straight line. As where Woods, at least per my estimation, has not quite as straight a line. It's if we are forced to draw a straight line, it would be kind of more of a flat line than an upward sloping line. There are points within Goff and Woods' range of outcomes where we do have kind of more linear or more strongly positive correlation, but in general, across kind of the range of outcomes for these two players, it's not super tight. There is a decent amount of variance, and that's why you see that lower correlation. Just one note about this plot also, if you hover above the data points, you can just see information about that data point. So we're looking at this data point, and you'll see in the parentheses up top, that's just an XY coordinate. So in this week, Goff scored 29.5, Woods 36.7. You can see the combined fantasy points, so just those two numbers added up, date, team that they played on. So like for example, Brady and Gronkowski have data points together, but on two different teams. So potentially useful to understand kind of on what team these correlations occurred. The opponent they played, so understanding if maybe ceiling, coordinated ceiling performances happen against only bad defenses or information like that could be useful. Score, and then whether the game went to overtime. So I think all this is useful information for developing hypotheses around how players relate to one another. There's a number of different sets that we can look at. Like I've mentioned, we can compare multiple sets of players, and by typing in multiple players in each set, we will get the correlation of all crosses or combinations of those players. We can also look not at specific players, but at like groups or units of players. Um, Not so much within the same team, but I think with game stacking, there's a lot of interest in how players relate to the performance of their opponent, right? When we are quote unquote bringing it back with a player, we're really selecting a player on the other team that we feel has an elevated chance of succeeding when a group of players that we're stacking also succeeds. So, looking at how different players correlate with the opposition, we can type in something like OPPT, opponent, uh, specific positions, or just the offense as a whole. So this would be the sum of the sum of fantasy points scored by opposing players in games which they oppose Goff and Cup. And we can see that in general, both these players positively correlate with the cumulative performance of their opposition. We can plot it out. We can see that, for Goff's floor to kind of median outcome, there's little, positive correlation. But as Goff really reaches ceiling performances, it tends to correlate with elevated scoring by the opposition. And in theory, I guess you could say that games in which the opponent is doing particularly well, putting up lots of offensive fantasy points, might be games in which Los Angeles Rams are trailing, therefore Goff is passing more, or vice versa. Maybe Goff has put up a lot of points through touchdowns, therefore the opposition is trailing and going to a pass-oriented kind of up-tempo offense. That's the thing about correlation is it's not really causal in nature. You're not saying player X's performance causes player Y's performance or vice versa. It's really just a measure of how frequent simultaneously similar performances relative to players' norms, how frequently those similar performances occur between two sets of players. So another example of a correlation use case is studying how inactive players are likely to impact performance of other players. So most recently, there was an instance where Tyler Higbee was ruled inactive, and I was curious to see what players stood to benefit from Higbee's absence. And conversely, I think you could study what players, when inactive, Higbee tended to benefit from. The idea being that their roles are not so much interchangeable, but that they compete with one another. So the absence of competition from player X would generate, I guess, more opportunity for Higbee. Conversely, we might be able to apply that by Higbee being out, maybe player Y might have some elevated role or performance based on that. So, I searched Higbee, and compared him against like Josh Reynolds, Gerald Everett. These were players, I guess Robert Woods as well, players we were interested in uh, viewing correlation versus Higbee. And notice some slight negative correlation from Reynolds, thinking that maybe uh, a reduced role for Tyler Higbee because he's inactive would yield more opportunity from Reynolds, and conversely wanted to understand if uh, inactive games for Josh Reynolds might yield more opportunity for Tyler Higbee. So we have this drop inactives checkbox, which is just a logical checkbox that says if a player is inactive for a game, don't consider those outcomes or games or outcomes from those games as possible data points for correlation because that player didn't play. So it's kind of difficult to understand, how player X relates to player Y in games when player Y didn't play. Um, that's going to be the default for the application, but by unchecking drop inactives, we can coerce games in which a player is inactive to um, be counted as zero. So essentially that player had no role. So find negatively correlated players, players who achieve ceiling performance when player X, Tyler Higbee, has minimal performance. Or in theory, a game in which Higbee is inactive is a game in which Higbee has, minimal role, zero, zero, zero fantasy points. And I thought this was like a useful way to try to find players who stood to benefit from Higbee being inactive. At the end of the day, I think we kind of landed on obviously Everett as potential guy because he is the tight end kind of behind or aside Higbee. So totally makes sense that he would negatively correlate games in which Higbee's out. Everett likely to have an expanded role and vice versa. But I also landed on Josh Reynolds as a possible player who might have an elevated role if Higbee was out. I guess in theory, or I guess in application, you see that games in which Josh Reynolds had minimal role, some of those, at least some of these ones out here and like right here, are games in which Higbee had really solid game. Games in which Reynolds had you know minimal role, Higbee had even though Reynolds was active, clearly putting up points, Higbee had great performances, and kind of vice versa. Like games in which Higbee had really low scores, we see this kind of small set of points out here, where some of Reynolds' best games came in games in which Higbee had a minimal role. So this drop in actives, I think, is kind of a useful way of comparing players and particularly trying to find negative correlates who stand to benefit from injury. Um, so yeah, I hope you guys might find that useful. And I think negative correlation is like a really good approach, or negative correlation pairs are worth considering. They're players that we don't want to play really with one another, but offer us great leverage opportunities. I think like a classic example is Aaron Jones and Devontae Adams, who I think historically have some degree of negative correlation. Uh, Looks like most of that is really coming from this one game where Jones had a huge game and Adams had uh, very minimal production, only 6.6 fantasy points. But you see some more. I mean, some of Adams' best games have come in weak Jones games. So this type of relationship is useful to understand, not because we want to stack them together, but because either player could be used as a particularly advantageous leverage piece if we want to build lineups that are different than perceived chalky build. So in a game in which Devontae Adams, or sorry, slate in which Devontae Adams is projected to be super high ownership, and we want to purposely build lineups that are different from uh, our opponents who are in general building a lot of Adams heavy lineups. A guy like Aaron Jones would be a player we would target because of his negative correlation. I'm curious, like if Marquez Valdez-Scantling looks like doesn't really have, you would think like, oh, well, two receivers compete with one another for targets. So MVS and atoms would have negative correlation, but it looks like we're actually seeing somewhat positive correlation between one another, such that we might be a little dubious of trying to use Marquez Valdez-Scantling as a leverage piece against atoms, because historically in games which MVS has really excelled, those have also been pretty good games for atoms, such that we might be a little less interested in using MVS as a leverage piece. And by simply looking at these two guys correlation metrics, which with atoms, I think we can quickly see which player is kind of a preferred uh, leverage piece against Devonte Adams. So I hope all that makes sense. And if you guys have any questions about how to use the application, or more generally how correlation can be leveraged or used for lineup construction, be happy to try to answer those questions via Twitter or an email. Also encourage you to check out our YouTube series with Roto Grinders and Jordan Cooper. We discuss at length correlation, both negative and positive, and its possible applications on a slate specific context. So I really encourage you to check those out. I think those might be helpful if you're trying to come up with ideas or ways to use correlation to your advantage in lineup construction.